All right, let's continue our adventure learning about limits. Today we're going to look specifically at those infinite limits. So these are limits that are actually shooting straight up or shooting straight down or maybe from both sides. So this video should be hopefully relatively quickly, and I think it'll be pretty easy for you to understand. So let's get right to it here. We're almost done with this entire boot camp, but today we're looking at these infinite limits. So here we have some limits, and they are from the right. We talked about that in another video. They are from the left. We talked about that in another video. So it's important to remember how that works. So I already gave you the graph here, so let's think about these a little bit graphically speaking. So as we're coming from the right, that's what this plus sign means. So as we're coming from the right, as we get close to 0, here's 0, here's x equals 0. What is this function doing as we travel backwards on this roller coaster? As we come from the right, look at that. It's just completely going practically vertical. So that's why the answer there is, what do you think? The answer here would be infinity. So the limit as we approach 0 from the right would be infinity. Let me erase this circle here, get it out of the way. Now going back, what about coming from the left? If we ride the roller coaster from the left, what is this thing doing? So it's going like this, and then it's dropping incredibly steeply. It never actually gets there, never actually gets to 0, because after all, there's a divide by 0 error. If we try to plug x equals 0 in there, it's not allowed. So as far as the domain goes, x is not allowed to be 0 here. So what's happening? We're going to negative infinity. That's pretty easy, right? Negative infinity. Now, what about the limit just at 0? If I said, what is the limit at x equals 0? Does it exist? Well, the right does not equal the left. Remember, we talked about that previously. In order for a limit to exist, the right has to equal the left. So this would be a does not exist situation. See, that's pretty easy, right? So then I wanted to give you an example where they're going the same direction. So here's a perfectly good example. 1 over x squared. What it does is it flips what used to be down here. It flips it upward, and of course it's squaring all the numbers, so they get bigger faster. I guess it's a little steeper. This corner right here is a little steeper. Anyway, let's go through the limits. What about coming from the right? Positive infinity. Easy, right? Positive infinity. What about coming from the left? Also positive infinity. So this time, what about the limit at 0? Does it exist this time? It sure does. The limit at 0 this time is infinity. They're both going the same direction. So as we imagine plugging numbers closer and closer to 0 into this, as we approach 0, the fraction will be spitting out really large positive numbers, either coming from the left or the right on the table. Okay. What about this one? So this time I didn't give you the graph. So let's think about this. Do you remember back in Algebra 2 and also Pre-Cal, you learned something. What did you learn about expressions like this? Negative 3 over x minus 2, specifically that denominator. Well, there is a vertical asymptote at x equals 2. You should recognize that from your work in algebra and pre-cal. Now, because this factor doesn't cancel another factor on the top, it's not a whole. So we know it's not a whole. We know it's an asymptote. So let's go ahead and sketch that in. I'll use a different color here. So at 2. So I'm going to put a dotted line right there at 2. We know there's a vertical asymptote at x equals 2. Now, we have to analyze this a little bit because, again, we're not going to Desmos here and seeing what this is like in Desmos. Instead, I'm trying to do this without Desmos. So, x minus 2 is greater than 0 coming from the right when x is bigger than 2. So over here, that denominator will be positive. So on the right side, the denominator is guaranteed to be positive. So what do you get when you take negative 3 divided by positive? What do you get? You get a negative number. You get a negative number. So this thing must be in the negative region as we're getting close to 2 there. Okay, so this graph goes down like that over there. So we know that the answer to the first one, is negative infinity. You see that? Okay. Now let's talk about x minus 2 is negative when x is less than 2, right? When x is less than 2, like 1.8, 1.5, 1. All those numbers, if we plugged it in right here, would give a negative value. So what is a negative divided by a negative? Positive. So that means on this side, this thing is going to positive infinity. Positive infinity. And let's fill in that answer. Positive infinity right there. So what about the limit at x equals 2? Well, of course, that would be does not exist, since the right doesn't equal the left. Now, if we were to finish this graph, go to Desmos, you can check it. It will look like this, because this limit, and we'll talk about this in the next video, but we have horizontal asymptotes here. As we imagine plugging bigger and bigger, either positives or negatives in, we are approaching the number 0 as we get close to that. All right, so hopefully this video was helpful for you, and now you know all about infinite limits. They're really easy, especially when you have the graph. All right, so check out the other videos in this sequence. I want you to be a pro at working on limits for your class, and maybe to take that final exam or the AP exam. All right, until next time.